everyone, we're going to verify this trig identity, and normally what we'd do is work on the more complicated side, which seems like it would be this right hand side. But when you're looking at this, what I notice is we have three terms here. Here's one term, three terms. Here we have the same thing. The more you do this, and by the time you get to this problem, you've probably done a few trig identities by now. I notice this 1 here. When you see the 1, I notice that I could divide both of these sides by sine squared and get 1. And if I do sine squared, I'll get tan squared. So what I'm going to do is take my problem and look at sine theta times cosine theta. And I'm going to multiply this by 1 divided by cosine squared of theta. Or it's the same as dividing by cosine squared. And also do my numerator or denominator that way. So I get cosine squared of theta minus sine squared of theta. And I also want to multiply it. You have to do both the numerator and the denominator the same way. So what that gives me in the numerator is cosine. Remember, this is like in fraction form. Cosine goes into cosine squared one time. So you have now sine divided by cosine equals tangent. All right, and then for this one, if you distribute, you have cosine squared divided by cosine squared gives you 1. Then you have minus, and then when you multiply these two, you get sine squared theta divided by cosine squared of theta, which is tan squared of theta. So your final answer is tan, or your proof actually, tan of theta minus 1 minus tan squared of theta. So we did prove it, and a lot of it is just keep looking at what you want here and noticing this 1, and you have to start noticing more, which only happens when you've done quite a few trig identities already. That's it. Thank you. Have a nice day. Bye-bye.